All right, today we are starting our last section for this chapter, determinants and inverses. And we're really going to focus mostly on determinants. A determinant is a number associated with a square matrix having real number elements. So the determinant of A is written as DETA, and we'll go through a little bit more how to show that. What the determinant is, and you might want to write this part down. If we have matrix A, that's A, B, C, D for elements. This is a 2 by 2 matrix. The determinant is going to be A times D minus B times C. So we're kind of going along the down diagonal first, and then back to that up diagonal here. And then whatever value we get, it's called the determinant. So our whole goal is to be able to find the inverse and the determinant of a matrix. And then something that we need to make sure we understand from this section is the product of a matrix and its multiplicative inverse matrix is the multiplicative identity matrix. And not all matrices have inverse matrices. And we'll talk a little bit more about that. Okay, so a square matrix is a matrix with the same number of rows and columns. Like this is a 2 by 2, 3 by 3. It looks like a square and it makes sense. Every square matrix, as it says here, has a multiplicative identity matrix, but not all of them have multiplicative inverses. So that identity matrix, it has a definite look to it. If we have an n by n matrix, it could be 2 by 2, 3 by 3, 4 by 4, whatever, the identity matrix has ones all along this main down diagonal right here. So here are our ones, zeros everywhere else. Here are our ones along that main diagonal, zeros everywhere else. This last piece just says if they're square, so 2 by 2, 3 by 3, 4 by 4, AB is equal to BI, or excuse me, AB is equal to BA is equal to I, that identity matrix. If that's the case, then B is the multiplicative inverse. And it's written like this, just like it was with sine, cosine, and tangent. Okay, let's actually check to see if these matrices are multiplicative inverses. So multiplicative tells us that we need to multiply these two, and inverse we are looking for when we multiply them together that we're going to get this identity matrix. That's how we know that they are inverses. So we're going to take these two matrices here and we're going to actually multiply them. So setting this up, going to look like we have 2 times 2, so we're going to have 4 here, plus 1 times negative 1/2. Oops, sorry. No. 2 times 2 is 4, plus 1 times, there we go, negative 3. Okay, moving on, we do 2 times negative 1/2, which is negative 1, plus 1 times 1, which is 1. So negative 1 plus 1. And then here we move on to that second, I'll change colors, second row. 6 times 2 is 12, plus 4 times negative 1/2. Oh, I did it again. Plus 4 times negative 3. There we go. Minus 12. And then 6 times negative 1/2. Negative 3. Plus 4 times 1 is 4. And when we simplify all of this, we get 4 plus negative 3 is 1. Negative 1 plus 0, or plus 1 is 0. 12 minus, that's a minus sign, 12 is 0, and negative 3 plus 4 is 1. So here we have that identity matrix. So these two, yes, they are inverses. We can do the same thing here to check to see if they are inverses. You just have to be a little bit more careful of keeping track of all of your rows and columns. So we would multiply this row first by this column, and so on. Then this column, then this column. Okay, so that's how we check to see if something is a multiplicative inverse. This next piece deals with the determinant. So if we are going to write the determinant of whatever your matrix is, A, it looks like this. We read it, the determinant of A, and we evaluate it like I said before, the down diagonal and then that up diagonal. And we subtract those two. So we're going to end up, if we have A, B, C, D, again, it's A, D minus B, C. And if we have a 3 by 3, it gets a little bit more complex. Because when we're doing our up diagonal, there's not just one. We have this one. And then, in order to find the next one, it's kind of like doing B, C, and then back to A1, which is right here. But instead of going back up here, B, C, back up here, and trying to keep track of all that, we can write them right next to each other. So you can see it says right here, copy the first two columns. So we have A1, A2, A3. Same here, A1, A2, A3. B1, B2, B3. B1, B2, B3. So that's all we're doing here to make sure we do multiply all the way across here. And then that also helps us when we go down diagonals all the way across here. So we get all those values without having to try to think, okay, what would be back to column 1? We just write them next to each other. Okay, so let's actually try this first one here. To find the determinant. So we're going to start here, multiply. 4 times 3 we get 12, and then subtract. Negative 5 times 1, so we're going to subtract negative 5. So we get 12 plus 5, change that to a plus, and the determinant of A is 17 of this matrix. I guess I called it A. The determinant of the matrix that goes with number 4 is 17. Okay, the next one we're going to try is number 5 here because it's going to have us copy the first two columns. Remember how I said that? So right next to here, we're just going to copy them over again. It helps us with that multiplying. So we have negative 1, 6, 5, and 3, negative 2, 7. Okay, and then now we're going to multiply our diagonals here. And if we go back, you'll notice that we actually take each one of those and we're going to add them together. These are those up diagonals. And then subtract from those up diagonals the down ones, which doesn't make a whole lot of sense now, but it will here. So we're going to do 5 times negative 2 times negative 4. So that gives me 40. All right, and then we're going to go 7 times 8 times, ooh, I'm a little off here, negative 1, and we get a negative 56. And then negative 3 times 6 times 3 is negative 54. Okay, from there we're going to subtract. Going the other way here, so we're going to do, oops, that's not enough room. Negative 1 times negative 2 times negative 3. So that gives me a negative 6. Plus, we're going to have 3 times 8 times 5, which is 120. And negative 4 times 6 times 7, which is negative 168. Okay, so here, 40 minus 56 minus 54 gives me negative 70. Minus negative 6 plus 120 minus 160 minus a negative 54. So really that's plus 54, and my determinant is going to be negative 16. So we just have to remember this part right here. Copy and paste that over, basically, those first two columns to make sure you have enough to keep multiplying. All right. Let's see here. We're going to save the rest of this part on inverses until on Monday. So I just want you to try the determinant stuff and the fact that we did learn a little bit about inverses. Here, if their square matrices AB is equal to BA is the identity, then B is the multiplicative inverse, and then we write it A inverse just like that. So these two we could say are multiplicative inverses. So we did learn that much, but we're not going to continue on with inverses. So your assignment, we're going to have to shorten we're going to cross off for today, probably coming back to it, but not sure. 28 to 32 even, gone, 36, and so this chunk is going to be gone. You're going to do 1 through 5, 7 through 23 odd, and 64 through 60 or through 72 for the weekend. Let me just double check. Yes, those look great. There's at the end of your assignment there, I threw in some semester test type review questions, so make sure you get to those and understand them. All right. Good luck on your homework.